Hi everyone, and welcome at the first episode of the AI Talks. I'm very excited to be your host today, and with the global AI community, we've reached already more than 10,000 people in over 80 countries, so that's quite a lot of people already. But it's not enough. There's so many more people that we would like to reach, so because of that, this new initiative. We're going to host a bi-weekly show where we're going to have people from all over the world who will give theoretical sessions, practical sessions, deep dives, technical deep dives, and so on. Maybe you're just a junior, or you're an expert, or you're more into business-minded. Well, we'll try to satisfy all your questions. But today I have a special guest. We have Seth Juarez with us. Welcome, Seth, to the first episode of the AI Talks. We're very happy to have you here. Please introduce yourself. Who are you? That's cool. So where are you focused, Seth? Where are you based? Sorry. Oh, that's cool. So we have approximately, how much? 9 hours difference right now between me and yourself, but still, here we are. So the technology brings us everywhere, and AI does it even further. So, Seth, what do you want to talk about today? Okay, Seth, just give me a second. People don't hear you.
Okay.
That was a mistake by me.
Oh, okay.
Thank you, Ivana, for telling us.
Fantastic.
Okay, can you just introduce yourself again, Seth? My
Absolutely.
mistake.
No problem. My name is Seth Juarez. I work for Microsoft. My job is as a cloud advocate. I help developers be successful with AI in the cloud, however people want to do it. And today, I thought, since it was the inaugural episode of AI Talks, that I would do a primer on AI and machine learning, and maybe answer any questions and show you briefly how Microsoft thinks about it. But if you'd like me to show anything else, like I said, Sammy, you feel free to interrupt me when the viewers have any questions, just totally interrupt me. This is all for people that are watching. And so I'd rather answer questions and show stuff that you want me to show as opposed to whatever I want to talk about, because you're more important when it comes to this kind of stuff. Does that work?
That's perfect. Let me tell the listeners or viewers, if you have a question in YouTube, you just use the chat box. Just tell us what your question is, and then I will ask Seth the question. If you're watching through the link on the Global AI Community website, just click on the link to go straight to the YouTube page, and from there onwards, you will see the chat, and we can go onwards. So, Seth,
Fantastic.
I'll give the words to you.
Fantastic. So hopefully you should be able to see my screen now, and you'll see me in the bottom half of the screen as well. Basically, what I want to do is I want to do just an intro, and stop me if there's anything. Like I said, I'm more interested in what you all have to tell me. So the first question that I always like to put out there, so we can get it totally out of the way, is what is this thing? Because people talk about artificial intelligence all the time, and sometimes they talk about machine learning too. And my sense is that there's some, at least for me initially, there was some confusion between the two. But artificial intelligence is actually a pretty large thing. And imagine artificial intelligence is this bubble, which I shouldn't say in tech talk because technical bubbles are usually bad, but it's not in this case. Artificial intelligence are any algorithms that may seem intelligent or may have human-like qualities, right? The Turing test is a famous test from a long time ago that Alan Turing came up, where if you interacted with this thing, if you couldn't tell if it was human or not, then that was artificial intelligence. We have since learned that it's actually a little bit more than that. But artificial intelligence, again, is any algorithm that makes things look intelligent. Now, Some people have this sense that this field is actually new. It's not. It's quite old. This comes from the 1950s. And there's some algorithms, for example, that you interact with all the time that are intelligent, but that are not the kind of intelligence that people generally market today. So, for example, if you were to build a tic-tac-toe solver, it would be pretty easy to do because the states are all finite. Basically, you could draw I'll just draw it because I have screens and stuff. So basically, if you had a tic-tac-toe thing like this, right, you could basically say, okay, I'm going to put my O here. What the computer can do is it can say, okay, if I put the X here, here are where all the O's can go. And then that's one state. And then another state could be, well, if he puts this X here, then here are all the other states. And this problem now becomes like a search problem, in essence, where you're just trying to find the path towards winning. Other algorithms, for example, like in Waze, that find you the best and optimal path to get to work or to get to where you're going, are similar things, except the difference is you have things that are called heuristic functions that tell you which thing to do next that shorten the search space. So all of those are artificially intelligent algorithms. And I like to think of them as glorified search, like breadth-first search, depth-first search. Those can all fit in the category of AI. I personally like to call it hard AI because the search space is fixed. But then there are certain artificially intelligent things where the search space is not fixed. Like, for example, looking at all of the pictures in the universe and figuring out which ones are cats. Notice that the search space is infinitely larger because anyone can do any number of pixels, etc. There are a class of algorithms called machine learning where it's not a search problem, but instead you're giving it examples of the right thing and then it figures it out. That's what basically machine learning is. Deep learning is a subset of machine learning that deals primarily with neural networks. And so there's a class of machine learning algorithms called neural networks, and if they happen to be super, super, super deep, then those are considered deep learning. How deep the neural networks have to be deep learning depends on the marketing guy, which is unfortunate but true. So just to recap, programming generally is when we make a function, we give it some input, and out comes the answers. Machine learning, which is what I'm going to focus on today, which is a subset of AI, but again, people use it interchangeably, is when we give answers and the input, and out comes a function. And in data science terms, this is called the data, and then out comes this thing called a model, which, as far as I'm concerned, is an alternative way of writing a function. So a model, think of it as a function that does a very specific thing, but instead of it being programmed, it was actually learned. And that's the difference. So when you see a machine learning model, and if you like, I can show you one. We'll literally just open it up and you can look inside of it. It's basically an alternative way of writing a function that instead of writing an algorithm or a set of steps to solve the problem, it is instead learned from data that you give it. And then sometimes it's an open question how this is actually done. But in reality, we're basically trying to make a function. But instead of programming it, we give it data. Now, the reason why this is a potentially hard thing is because it's not as magical as you think. You actually have to pick from a large set of things, and we'll get into this a little later if there's time, but you actually pick from a large set of model shapes, a large set of parameterizations, and you basically, the question I always get is, well, how do I know how deep a neural network I should build? Or how do I know if I even should use neural networks? Should I use SVMs? And the answer to that question is you have to use this pesky little thing called science. And this is important because the best data scientists have this hoarse sense about what it is that's actually going on, and they can figure out things faster. But the only way to know what kind of model style to use, what kind of parameterization to use, if I even should be using neural networks, is you have to try stuff. And generally for data science, this here is the loop of sadness, where things may not work initially. And so, and the other thing for data scientists is that if things do work perfectly the first time, there is generally a lot of nervousness because something is terribly wrong, right? So there are basically three options that you can choose whenever you're actually going to be using machine learning models. You can use models that have already been built. You can enhance models that have been already built, or you can actually create your own. Now, just like, for example, if you're a programmer, a data grid. How many of you have ever written a data grid? And if you have, that's awesome. If you haven't, you generally just use some that you buy. And the same is the case for machine learning models. And when it comes to how it's done on Azure, we have basically a couple of options that you can choose whenever you're trying to do this kind of thing. So if you want to use pre-built models or enhanced pre-built models, you can use something called cognitive services. But also, if you want to enhance models in the programmer way, as a data scientist, you can use something called Azure Machine Learning Service, which is actually pretty cool. And I'll show you just little bits of it. So let's start with cognitive services. You may have heard of them and you may haven't, and that's okay. Cognitive services are basically intelligent algorithms or models that have already been built. And what's super cool about this is that you just basically use them. So here are the ones that we have. We've basically found that there are intelligent services that everyone needs with common scenarios, for example, vision, speech, language, decision, and search. And they're all, you just basically can use them, which is pretty cool. Now, if you're not a fan of Azure, that's okay. If you're still trying to solve these kinds of problems, I would look at every cloud vendor, or maybe even just say pre-built AI models, and then you'll be able to find solutions there. But the goal is that you should be able to use AI just by calling one that's already been built. So I thought what I would do is I would talk a little bit about some of the services we have, not necessarily by talking about, but by showing you how they work. So, all right. So hopefully you can see, Sammy, my screen where it says cognitive services. Are you seeing that right now?
I can see everything perfectly.
Perfect. All right. So basically, cognitive services is a comprehensive family of AI. Blah, blah. That's nice. But I want to show you how it actually works. Now, I am a vision guy, not like I don't give TED Talks, but I like computer vision stuff. And it's really fun to play with these kinds of things. So you can literally go to these things right now if you want. Go to azure.microsoft.com or just Google with Bing cognitive services and you can try it. So we're going to go to computer vision because I'm a fan of these things. Oh, look at this, a webinar. How cool is that? So let's try with a picture maybe that let's see. Let's go to my Twitter account. Twitter, and then we'll pull up my picture here. There I am. Let me open this image in a new tab. Okay, so there's me and my lovely bride. Let's see what computer vision sees in this. So I'll just hit submit, and everyone can go and try this literally right now. It's fantastic. So look at that. It found a person. It found my face. It found another person. You can see here that it has a person with confidence 0.999. It looks, there's other tags. There's outdoor. There's a tree. There's a smile, human face, clothing. It found some rectangles of the actual people, which is super cool. There's some descriptions: person, outdoor, standing. Now, I did this demo once with like a famous person, the guy that ran MSR.
Well, I see you also added to the famous people already. It recognized
this is the joke. This is the joke. Like basically, and Sammy, you're gonna love this. I got on stage with a guy by the name of Harry Shum, right? And he runs MSR. And so basically, I made a joke that like, oh, I'm not super famous, and so it won't show up. And maybe people were like watching that, the devs, because they knew their boss's boss was on there. And so they added me. And so if you see right here.
How cool is that?
I know, right? So now, according to our AI, I'm famous. Although I am a little concerned because my wife's name is not Al, which is an important thing.
So who is Al?
I don't know. Seth et al, right? They're using some Latin there. So this is cool. There's also face recognition, right? There's a bunch of stuff that this will do. It's pretty cool. You can literally just call them. There's a tons of other ones. Let's see if this will work. Let's see, speech to text, because I'm using like microphones already, so I don't know if this will work. Let me try to see if this will say whatever I want it to say and maybe even write it down, because writing stuff down is super cool. And notice that I'm really just talking in my regular voice. See that? And so this is an AI that you can just call, which is really cool. The other thing is that you can actually generate speech, and you won't be able to hear this, unfortunately, because I should have set up so I could push my computer audio to you, so you could have heard it, Sammy. But I don't know if you heard that. That's okay.
No,
So
that's coming
basically,
through.
so basically, this will say whatever it is that we type into it, which is amazing. And maybe I can. Well, for next time, I should have added send my computer sounds over, but I didn't because I'm silly like that. But basically, you can see that all of that is something that you can do. Maybe I'll be able to fix it here real quick. Let me check my audio source here, audio and video settings. So microphone, we're going to use the, let's see. No, it looks like you lost my audio there for a second, so
Yeah,
it's not.
it was gone.
It's okay.
No problem.
Okay, so that's the custom things that you can actually do, and you can try all these out. There's others for language, for example, text analytics, which is really cool. You can basically type in something like "I hate pants," right? And because I like shorts, I was born in California. Notice that it's English. The key phrase is pants, and it's like this is super negative about pants, but you get it back in this cool little JSON format, which is really nice.
If you
Oh,
go back to the speech one, what I personally like a lot is the neural voice, how natural it is. That's
yeah,
it's
so. Go here,
crazy.
go to speech, and just click on this, and you'll hear the thing. And I don't want to get ahead of myself, but there's the next set of things. For example, like what if you want to enhance pre-built models? I'm going to talk about custom vision, but I'll throw in also speech. So hopefully you can see custom vision there,
Yeah, I can see your
which
slides.
is something that you do, like if because we already have really cool models at Microsoft. But what if you want to like look at very specific pictures that only relate to you? Let's just say you're a hardware manufacturer, and on the assembly line you want to make sure that the parts are not defective, and you want to build an AI to do that. Notice that our regular computer vision won't work because it's never seen that style. It only works for generic or general things. And so you can use things like custom vision to build super cool things. Let me get my other face out of the way so you can see all my other faces. So this is a rock, paper, scissors game that I made with the computer where I literally just upload things to rock, paper, scissors. And the cool thing is, here, let's just go to it because I have it up here. This is me doing the demo somewhere else, right? But here's rock, paper, scissors, and it's pretty cool that you literally just add the image, give it a tag. Here's a dumpster fire that we're not going to put up there, and you can choose like none or paper or whatever. And this is how you train these models. You literally just click this button, and then whenever you give it new pictures, right, it will predict whether it sees a rock, paper, scissors. Now I have my camera. Let's see if this works here. I don't know if it's going to work because I'm already using my camera. What a bummer. But basically what it does is this, if you go to this thing right here, you'll notice that it may or may not see the right thing, but that's okay. You can train it by giving it new pictures, and then it will learn. Now, the cool thing about this is these models that have been enhanced to know about rock, papers, and scissors, you can basically export and lift and shift down. And like I always say, things aren't real until there's a JavaScript version of it. That's right, friends. you can run this on the browser, which is pretty cool.
That's very, very cool. What I love the most is that you don't need to be a data scientist or have deep knowledge of deep learning to build this kind of models. You can just, anyone with some technical skills can just build something.
Yeah, absolutely. Like 100% agreed. And that's the cool bit. And so as you're looking at this, you basically hit a button to train, and then it doesn't. Usually what you need like 50 images in each class, and that's enough. Because what we're doing is we're enhancing a model that has already been pre-built. Fantastic. And so notice that you can download those things, as I said before, which is cool. Notice before I only had like 15. I added more because it's red when it's like, hey, you might need more pictures. And so it's doing that, which is really cool. Okay, the last thing that we're going to talk about is if you want to make your own models, that is awesome. This is where I live a little bit more. I love the other things for demos because they're really quick to make and to use. When you're building your own custom models, though, you have to be considerate of a process of how this is how you do this. So let me get my face out of the way there for a second. So Azure Machine Learning and basically all machine learning processes go through this prepare, experiment, and deploy, and then there's like a loop back to redo all this stuff because models can and will get stale. And so basically you prepare the data, you can build your model if you like Jupyter notebooks, that's awesome, whatever. In Azure Machine Learning, we have this ability to train test models, register models, build images, and deploy services, and then monitor the models. So this is what this looks like. We'll get to it in a second, but basically these are all the things you can do inside of Azure Machine Learning Service that a data scientist would like. So now hopefully you can see Azure Machine Learning Service is right here. There you go. There's my face, so you can see it. There's a couple of cool things that you need to think about whenever you're working with these things. The first is there are things for authoring, quick authoring. These are all in the Enterprise Edition. And then there's this notion of infrastructure for actually doing all of the experiments, etc. And the cool thing about that is this enables end-to-end machine learning to happen as a team sport, which is actually really cool. And then in here is where all of the goodness happens, because as I said before, when you're doing machine learning, it's kind of like an iterative process where things will not work initially and then things will start to work. So the question for those that are building custom models, and I want to spend like 2 minutes on this and then we'll go to questions, is where do I start? Well, in my opinion, you should start with something called automated machine learning. And the cool thing about automated machine learning is that it basically will choose a model for you. So let's go ahead and show you how to do that. So I'm going to choose my clothing data set. By the way, let me show you what the clothing data set is. So we'll go to a data preview. Notice that it's some text and a rating. And basically what we want to do is we want to be able to, given text, predict what the rating would be. So I'm going to select that data set. I'm going to hit next. Then I'm going to give it an experiment name. I've been doing this as a clothing experiment, so I should pick that. The column we're going to learn is the rating. And the compute environment, as you can see, like I am a fan of, these nerdy things. So I'm going to pick Gandalf. Oh, no, this is going to be a Wicked training, so we'll use Sauron here. And then I'll hit next. And the cool thing is it basically knows, like, the thing you want to do. In this case, classification is to predict one of several categories. Regression is to predict a numeric value. And time series is if you have a timestamp and you want to predict what happens in the future, you can do that if it has a timestamp, which is super cool. For us, it's classification because we want to select a 1, a 2, a 3, or 4, or a 5. Or we could try to make it a regression, but I'm going to leave it that. We also have this preview for deep learning, which is really cool. I'll just leave it checked. And then here's the cool thing. You can look at the features, which is the thing where you predict. I'm going to choose text. Oh, wow. Look at this. Is new. This is really nice. So new features are put in all the time, which
surprises
is really cool.
Every day.
Yes. And then, for example, you can pull, like, I'm going to block this algorithm. So for those that don't know, k-nearest neighbors basically memorizes the data set, and then it finds points that are close to it. So let's just say, like, there's blue points here and red points here, and all of a sudden you're like, oh, we want to predict this yellow point. What it does is it finds the k closest ones, like, oh, since those are all red, then I'm red. And I don't like this because it memorizes the data set, and that's not cool. So I'm just going to block it. Exit criteria is how long do I want it to run. Validation is like what kind of validation, and then you hit save, and then you can hit finish, and then it happens. This takes about 45 minutes to run. I've already run it, so let me go to this run over here that already happened, and here are all the models that it will like build for me, and I didn't have to do anything. Remember, a model is just a lazy way of writing a function, and so just think of it like that. And the cool thing about automated machine learning is that we actually, when we're doing this, if you say just do it, basically we will give you machine learning models that our AI model says would work the best for you. And so as the output comes out of the machine learning model that is currently running, we're like, well, if you like that model, you're really going to like this model, which basically is like an AI for building AI, which is scarily awesome. And so that's automated machine learning for you, which is fantastic. Last one that I'm going to show you is obviously tacos and burritos are super important. This enables you to do things like pipelined approach to machine learning, and they're in there. They're called ML pipelines. Here's a complete pipeline. If you want to look at this up, you can basically go to one that I've already built. So I'm just going to type it in here. Is https github.com cloud scale ML, and then you'll be able to find all the stuff here, /seer in this case, which is really cool. So that's the pipeline that's built there. But then you can use Azure DevOps to deploy these things like this, which is super cool. All right. So I'm going to have to skip this bit right here and go to review. There's something called model interpretability, which is really cool. It lets you like talk about like how these models are, what they're actually doing, but we don't have time to do that.
Which is actually very important, since if you build a model and you can't explain what's happening, we've seen many issues already around that.
Absolutely. So we have something called model explainability that I'm hoping we can get to maybe at a later AI talk with someone else. But it's really cool. It will find out, like, for example, what features are have the most predictive power. You can even do stuff like perturbation experiments, which literally means what happens if I change this feature. And so, for example, if you change male to female and all of a sudden it predicts the opposite thing, your model might be biased, and so we need to be careful. So a quick review. We did an introduction to AI, machine learning, and deep learning. We talked about machine learning models. We talked about the data science process. We talked about using pre-built models. We talked about enhancing pre-built models. And we looked at cognitive services, custom cognitive services, as well as Azure Machine Learning Service. Here's some links for some helpfulness. And I will go to questions.
All right. So, listeners or viewers who has any questions for the moment? If you don't
then Sam,
okay, shoot.
And then Sammy, if you have any questions too, I'll take them as well.
All right, no problem. I think from the people who are viewing, we don't have any questions at the moment.
Fantastic. Well,
so everyone understands everything. How perfect is that?
You know, better than me, in my opinion. Right? So,
that's true. I have a question though.
Yes, please.
Okay, let's talk about language generation.
Okay.
Which I find very interesting. The other time I was trying out the model that has been released by Open.ai, and the text that it generated was like, okay, wow, that was really cool. But now Microsoft, they didn't release yet, but they announced the Project Turing.
Okay.
With what was it? 100.
I haven't heard of it. I know they released something like was this week, right?
Yeah, it was. I think last week or something. But it doesn't matter. Mm-hmm. Yeah, but they didn't. It's that there were so many layers in it. The biggest model ever. So looking forward also to get a session about that. to share more about those kind of things.
That would be awesome. I do have some concern over the computational infeasibility of things moving forward. Because the deeper these things become, the more training hours they need, and it's interesting, right? Some have found, like, and maybe this is anecdotal, but for example, the BERT model, which is a really good, for doing transfer learning, you can use BERT to vectorize words in a really intelligent way, if I remember right. But some people looked into BERT, reverse engineered it, and found that, and again, this might be anecdotal, but found that they basically replicated the expert systems of the 90s with some additional rules.
Okay.
So
we do not always need to reinvent the wheel to make something better.
Yeah, but maybe this is a better way to do these things, because I can only imagine how long it took to do these expert systems too, right? So
true. All right, we'll wrap it up. Seth, thank you very much for joining us in the show. We hope to see you another time. Well, for sure we will see you in many other videos of Microsoft. So thank you very much, and have a good day.
Thanks so much. We'll see you.
All right, see you. So for our next session, which will be, we will have another speaker, of course. Next time it will be Terry McCain. He's an MVP based in the UK, and his session will be on the 12th of March at 6 p.m. GMT time, so that's London time. He will talk about Databricks and integration to or combining it with Azure Machine Learning services. So put it in your agenda, go to globalai.community/channel, where you can find a calendar item, put it into your agenda so you don't forget it, and we'll see you then back at the AI Talks Live. Thanks very much for joining, and see you next time.